Hey everybody, in today's video we'll be doing stock trading with fundamentals data. This is something I pulled directly from the AI for Finance, FinRL repo tutorial. It's in the introduction bucket. I really did nothing here to my own, so all the credit goes to those guys who put this together in this repo. But I did want to go through it because I think it's a pretty interesting notebook and there's a lot of cool features here that I haven't shown in previous videos. So let's just dive right into it. What we're going to be doing is talking about the description itself. We're going to install all the things that we need, download the data, process it, build the environment, train the agent, and we'll look at some back testing. And it's a pretty standard pipeline for doing a reinforcement learning task. So there you go. It's got a good pipeline there for you. So what is the actual task description? We're trying to uh, essentially trade stocks using the standard open, high, low, close, but for each stock ticker in our portfolio, we're also going to be looking at the fundamentals data to see if the agent can derive any other strategies that isn't totally apparent to us um, just through trial and error as humans. So it does give a nice little overview of like what the state space looks like, what the action space looks like, and the reward functions within the environment. That's something that they don't share in other tutorials. So if you're interested, you can pause the video and read this here, or just go to this web link here and check it out yourself. So we're going to be doing it on the Dow Jones 30 of the time, and we can get it using the we'll get the open, high, low, close volume using the Yahoo Finance, but the repo comes with its own fundamentals data. So one thing that we would need to do if we wanted an updated version of this is getting that fundamentals data, um, current to this time. In this video, I'm just using what they have stored here in their repo. Now, it will take a long time to go through this in real time. So I've already ran through the notebook and gotten the outputs from it, but you can see here that we're installing the necessary pre-requirements for the AI for Finance repository. You need Word, Swig. Since we're doing it in a we're also installing Conda Lab, Conda Colab because we're in the Colab environment. If you're doing it on on your local machine, you probably wouldn't need this part here. And then you need to also get a lot of these other dependencies here to make sure that you can build the wheels that are required. So, that's quite a bit of installation processes here that you need to go through. But I did run through it yesterday as of the making of this video, so you shouldn't have any problems with it. This is another list of the other imported packages that we're going to be needing. You can see that it's here. The usual suspects, matplotlib, numpy, and pandas. We're getting a lot of things from the FinRL. A lot of things I didn't even know that they had. For instance, like I had no idea FinRL had its own plot, um, part package or methods that you could call. So that's pretty interesting that we'll be able to look at here as well. But other things you've seen in other videos like the Yahoo downloader, feature engineer, data split, the environment itself is the stock trading environment. And then we're going to be using the stable baselines model, the DRL agents, but their FinRL works well with other environments as well. Not that are not stable baselines. You could use RLlib or elegant RL as well. We're going to be doing iter tools. We're going to be setting up some path folders if you want to save the model itself. And what's kind of cool about FinRL is that they come pre-installed with the getting the Dow 30 tickers list. So we'll be using that too. This just makes sure that we've created the actual directories in our folder because I'm not running the notebook, but we're not going to be doing that. Although it looks like I'm connecting, unfortunately. I don't know why. And then if you just want to see what the Dow Jones 30 is, it's these 30 stocks here. You can see it's like Nike, Microsoft, JP Morgan, Coca-Cola, Visa, Disney, Caterpillar, Apple there. So you can see it's a lot of the big giant companies, IBM, Home Depot, Goldman Sachs. There's a lot of the big companies, right? That we all are very big, well-known home brands. The data itself is going to be between 2009 to 2021. That's a pretty solid amount of time. So I don't expect you would need to include more, although you'll see in the shape of the data, it comes out to be just under 100,000 rows. So yeah, you might want to try to figure out if we could fill in the gaps to try to get it from 2009 to 2024 or something like that. This is what it looks like when you download it from Yahoo. You just get the pretty simple. You get the day in which happened, the date, open, high, low, close volume, and the ticker itself. Day refers to like which day. So if Monday's 1, Tuesday's 2, Wednesday's 3, Thursday's 4. So this happened on a Thursday. We just make sure that the date is in a datetime format, and we sort the values by date and ticker. So it rearranges it to look like this. And then we need to pre-process the fundamental data. So we need to actually import it. And we'll be using Words, which is the Wharton Research data service. They have the fundamentals data on their site there. It's actually Words is actually a really good place if you want to get, you know, pretty big pieces of academic data across different domains. We calculate the financial ratios on that, and you'll see that in a second what that looks like. And then we're also going to include things like the, price related ratios, price per earnings, things like that. So we can just grab the CSV file in the repo just by calling the URL and reading the URL as a CSV. It looks like this. A lot of the header here, the feature names, are not gonna make a whole lot of sense. They didn't to me at first glance. So we actually rename the items here. So data date is the date, tick is ticker, etc. So we omit those because we don't want those to be used. Which I guess kind of makes sense because what we really want. Interesting. Oh, gotcha. So the next part, so you'll see here that they've sort of labeled what the codes here actually mean. So LCTQ refers to the current liabilities, and they've put it out into item list here. It says omit items that will not be used, and that's because they're going to be used for calculating the financial ratios, and we're going to pass the ratios through to our agent and not the actual numeric values themselves. And so that's what we do. We rename the columns, we check what they actually are, and we then move on to calculate the financial ratios. So you can see this makes a little bit more sense. Current assets there, total assets, right? These make a little bit more sense on the right side than they do here. Like TEQQ, like I would have had no idea that was shareholders equity. So this part is probably really important because you'll need to know what it is that you're actually looking at. So thankfully they've already gone through and deciphered the coding there. This is what it looks like. We'll calculate the financial ratios. Same thing. We're gonna make sure that the date is in a datetime data type. And we're going to get the profitability ratios and the operating margin. We do that through a for loop to iterate over all the values that we need. You can see the formula here. Net profit margin, same thing, iterate through the rows, go through a few if statements to make sure that we're grabbing the right data values, and we're essentially creating a new series based on this formula here. Return of assets, return on equity. We do the same thing for earnings per share, book per share, dividend per share, right? These are all the Um, ratio formulas to calculate the cash ratio, the ratios that we're going to be passing through our agent from the fundamental book value. Or excuse me, the fundamental values that we just downloaded from the repo. Inventory turnover, right? This is a lot of good information here. And I do want to call out that this information, the part of the reason I really wanted to investigate this notebook is because I've done a lot of technical analysis as additional features to the data frame, and I really haven't had that much luck. But the fundamental data and the fundamental ratios, I think, more so than the technical indicators, actually provide some real world data representation of the real world. The technical indicators are great if you want to calculate, the movement of the data or the movement of the price itself, but it sort of loses the actual real world business information that you're actually trading with and that you're trading on. And to lose that context, I think the agent uh, is missing a lot of the context it needs to represent an actual buy or sell position or decision. So once we get through all that, um, you can see that we concatenate all of those different series into one, and now we have our own data frame of the ratios. This is the head, this is the tail of it, right? So pretty cool. If you got nothing else from this video, I would probably take a look at all of these formulas here so that you could recreate your own ratios if you need using other data that isn't found in this repo, right? You just make sure that the names, align to the information that you're trying to calculate. I think is actually really valuable. So this code here could potentially be a really good boilerplate code for calculating the ratios that you need in other fundamental data that you might be looking at. But anyway, so we've got our ratios data frame. We deal with the NAs here. Looks like they're just filling it with 0. And this is our final data frame. Cool. So now we got to merge the stock price data with the ratios in the data frame. We use iter tools to do that. Pretty simple merging of two different data frames. So I won't, go into that too much, but you can just see that how that's done here. And then you backfill the things using the rows axis. Interesting. Cool. All right. So now another thing that they do is calculating the market valuation. For instance, like the PE ratio, PB ratio, dividend yield, and whatnot. So we create new columns for that. We do the calculations that we need to fill in the values for those columns. We then drop the columns like here because we're intending to use these more than we're going to be using these. So we finally have a fully processed data frame here. You can see it's got the ticker, open, high, low, close volume, OPM, NPM, ROA, all the good. And then in the back end of the data frame, you can see we still have our cash ratio, inventory turnover, debt to equity ratio, the PE. Awesome. So this is a lot of great information, a lot of more grounded information than what we've passed in other videos. So now that we have our data all set, the next step is to create a market environment using OpenAI gym style. So we're going to split the data into a training and a trade period. We just use the data split to do that using the same train and test states that we've defined previously. And we're just, it's just good practice to take a look at the head of each one to make sure that nothing has gone crazy. And we're going to set up the training environment now. So usual suspects, the gym, of course, is what we'll need. And then we're going to create a dummy vector of our environment. The stock trading environment is already included with FinRL. They've rewrote the class here. I don't really want to dive too deep into it because this video would become exponentially longer. But if you're interested, you can read through what that environment looks like. I've used it in a lot of other videos on my channel. Um, we can just quickly skim over here how it's built and how it's set up. It's a box. Um, you can see that we're passing through this kind of information here. The reward scaling is obviously set up at the beginning. We've already gone over that. Action space, right? These are all things that you should be relatively familiar with FinRL. And if not, you can just trust it. Like, I'm not gonna say that I'm an expert here and know exactly what this code is saying, or I've never really done a deep dive on this code, to be honest. That's something that I do plan on doing, but I feel like I have a lot of additional work to get through, just to be honest. So here's an action, sell stock, do a normal sell. You can see this is the if and logic here, if else logic, I should say. Just doing some turbulence testing, trying to figure out how many shares to sell. We're going to be doing the same thing for a buy order. Again, make a plot. The step function is here. Excellent. Interesting. It's calculating the rewards into a data frame. It's calculating the Sharp there. All the outputs that we would need for logging recorded trades. Yeah, big class of functions here. The reset function, the render function, update the state function. Excellent. Get SB environment. So with reinforcement learning, there's some standard stuff here, but because it's a financial environment, you can see that there's other, like a reset function is pretty standard with all reinforcement libraries that you'll need, but and then these plotting and step functions are also pretty standard. Buy stock and sell stock are the main functions that you'll find in a stock trading environment, simply because that's the environment that we're working in, so you need those functions in there. Cool. As you can see, it's a pretty long class. I don't want to go through it all. Okay, cool. So we're going to define the ratio list, and we can initialize the environment, or I guess all we're doing here is taking a look at the state space and the stock dimension environment. So the state space is 511, stock dimension is 30. There's 30 stocks, but there are 511, I guess, features in the state space that the agent can observe at any given time. So it kind of makes sense, right? Because we have all those ratios and the high open, low close for each 30 stocks. So the parameters of the environment, we're starting with an initial amount of $1 million. You can see the buy cost percentage, sell cost percentage, the state space is what we've already defined up here. Stock space is already what we've defined. We've already defined the tech indicator list is the ratio list. Action space is the stock dimension and the reward scaling. So we've defined a lot of the things in our state space that we're going to pass through our environment, that we're going to pass into our environment so that it knows what exactly we are defining up here, way up here, right? If you remember up here, because we need to pass through all this information in order to initialize the environment so it can make its calculations with all the other functions. So it should be ready to go. We're going to train it, or this is vectorizing the environment. We're going to choose which agent we want. I just decided to use the A2C model, but you can see here that FinRL can support other models. We've passed through our environment, our training environment, which is the vectorized environment up here. Cool, and the notebook has all the models listed here for training. It just looks like this. and it will go ahead and it will do that. It will log it. It will create a temporary path for the A2C model, and it will push through all the things that we need to log for that model to our directory that we've defined. Since I'm using A2C, that's what we're going to do. And under this A2C model 3, we're going to then train the model. We've passed through our model, we're passing through our logger, our total time steps will be 50,000, and it will start training. And you can see all the information that we need, the entropy loss, the learning rate, explain variance, the policy loss, right? So we want the policy loss to get as close to 0 as possible. And I don't think we really ever get that close. You can see, yeah, let's try to get all the way to the bottom here. So after 50,000 time steps, policy loss is 176. That doesn't sound very good. Negative 68, 60. So wow, it's quite the variance. So it didn't get trained very stably from the very back end there. Okay, so we've trained it, but now let's trade with it and see how well it performs. We're just going to make sure that the trading data looks similar to our training data. We're going to set it up exactly the same way. We're going to grab from the prediction the account value and the actions. Remember, we used A2C. The reason it looks like this is because we could run all and train all of the models if we really wanted to. In this case, I'm just using A2C, so it's going to grab just the predictions and the actions, or the values and the actions. We could look at the shape and the head of all that, but we're not going to. So, okay, cool. So if we backtest it, this is how we'll backtest it. Again, it's just assuming that if we used one or the other, as long as this becomes like a true Boolean, then it will actually spit out the stats for the A2C. So these are the stats for the A2C model from when I ran it. Not very good. Annual return was 5% here, looks like. And it looks like the cumulative returns was 0.17. Annual volatility was 0.2425 if you want to round up. Sharp ratio 0.3, not the greatest. The higher this number, the better. So the fact that it's below 1 is not a good sign. Max drawdown, you can see, is pretty bad. So we do get a lot of this good information here, but we got to just assume what would happen if we just got baseline, like we just bought it and held it. We can calculate that as well. So the annual return is much better than our model. Cumulative returns are much better than the model. The volatility is much better than the model. So, well, actually, annual volatility is 0.27. Annual volatility up here was 2.25. Interesting. Max drawdown, -3. So it didn't perform too much worse than just buying and holding it. But of course, the ratio here is the Sharpe ratio is much higher. So we probably would have performed better just holding the Dow Jones 30. So even with fundamentals data, it doesn't seem to perform much better. But again, this is just me going through one model, pulling very stale data that's been just sitting in the repo, not optimizing this in any way, shape, or form. So I still believe in the idea of including the ratios over the technical indicators. I think in a follow-up video, what I'm going to do is use an ensemble method where we combine multiple models, A2C, PPO, because I've seen better results in previous attempts at this kind of thing. So I think I might try that and see if we can get better results here. And maybe I'll also show how we can source fundamental data for our portfolio if we don't want to use the Dow Jones 30, which I'm also a little skeptical of using as well. So there's another part to this where we can plot it, but when I went to go do it, I got this attribution error, no iter items in this here backtest plot. So there's something going on with this method here that I haven't really looked too deeply into, but we kind of already know what we're going to be looking at just from the baseline stats and our model stats here. So I hope you guys found this interesting. Go take a look at the repo yourself and read through it. I just want to make you aware of it, and just to show that reinforcement learning for trading is not this, you know, great method for making money. It's actually far more complicated than I've realized, and making a profitable agent is much more difficult than it looks. Probably for a topic in another video, I can go through why I think that is. But in the meantime, I will see you guys in another video, and take care. Bye.